everyone for sticking around and for bearing through our technical difficulties. We're going to be talking about simulating users with PowerShell in your lab environments. So just a quick agenda of what we'll cover. We'll do some intros in a second, talk briefly about why we made the tool and what kind of problems it's intended to solve and how it's supposed to help make your lab environments better, what the tool actually does and how it does it. We'll have a demo kind of showing pretty much every feature of the tool and it working. And then we'll talk about some future work that we want to do and open it up to questions. A note on the questions though, if you have questions during the talk, there's like 10 of us in here, so we can definitely just go back and forth. Feel free to interject whenever you want. So my name's Chris. I've been doing red teaming and penetration testing for about 5 years now. With no real specialty, I kind of done a lot of internals and externals, but then also web, mobile, pretty much all of the offensive types of assessments that your consulting firm will offer. Recently, I started building pen test labs with Barrett here to try to build a bigger focus on having realistic networks, fully configured Windows Active Directory environments, and kind of just making a lab environment where you can learn really what it feels like to do an actual pen test on an internal network, not just pop random vulnerabilities on boxes and then move on to the next one.
I'm Barrett. Also come from red team pen testing consulting. Enjoy writing tools. These are a couple of PowerShell tools I've written recently. Invoke PS image will encode a PowerShell script into a PNG file and then generate a one-liner to pull that out and execute all at once. And invoke WCM dump will dump passwords from Windows Credential Manager with PowerShell.
All right, so our tool is Invoke User Simulator. It is up on GitHub. It's been there for a little bit. So you can go download it, and if you have a lab environment already stood up, you should be able to just run this in there. There's some configuration functionality with it too, so it'll help you get set up. I don't think to date I've seen anyone put in like issues with it, so I'm sure we're not professional developers or anything. I guarantee there's some problems with it, so we're really open to if you start using it and find anything, let us know, and we'll get it fixed. So why did we make the tool? Kind of one of the most important things that we've found doing pen testing and consulting is that, especially in the InfoSec industry where everything is constantly changing and there's always new stuff out there, you really have to stay on top of that, and you really have to actually practice doing all the new techniques that come out. That means hands-on keyboard in a lab environment, actually running all the commands. So a lot of people do trainings or have labs that they run all the new tools and techniques in, but they tend to look like what you see on the left there. You're just running 4 or 5 VMs, if you have a lot of RAM on your own system. They're not usually very active. And if you're lucky, you might have 10 to 20 systems in a dedicated environment that your company runs or whatever. But when you go and do a real pen test on a corporate network, there's usually thousands of systems, and most of those have users logged into them, kind of doing their day-to-day tasks, creating that type of a lot of network traffic, different traffic on the systems themselves that makes it a lot different from your standard lab scenario. So we kind of built the tool as a way to close that gap. We can't make your lab have the thousands of systems that it needs, but it should at least have some normal user behavior. Kind of you can get that feel when you're practicing in it. Second main reason we built a tool is to enable other attack vectors when you're in your lab environments. So typically without any user behavior or network traffic, your man-in-the-middle attacks and your network stiffing is going to look really bland. You can't run Responder or TCP dump or Wireshark and have any of that come back like it's actually going to look like on a corporate network unless you've got, file shares getting mapped and internet browsing traffic happening. So that's the type of stuff that we're able to simulate and should hopefully make running those tools look and feel like they actually do on an internal network. And another attack vector is phishing. This is really kind of becoming a more popular way to get initial access on a network during a red team. So if you get phished, or if you're doing a red team and you send out a phishing email, you're not going to know what's happening to your payload on the inside of that person's network. So you can test it locally and do whatever you have to do to make it run, but once you launch it, it's kind of gone. And by having kind of our tool running a simulated user to open the email for you, if you have it running in your lab and you send out phishing emails to the users in your lab environment, you're not going to have to go on there and open it yourself. We had a customer recently who had a phishing payload that we saw them using in the lab over and over again, and we're wondering why it wasn't working. And when we looked at it, it was clearly broken. But so something happened where they tested it locally and it must have been fine, but then when they sent it off, something went wrong and it didn't execute when opened. So that's the type of thing that's going to happen to you in real life that, you know, if you're just testing locally or in a more standard lab environment, you might not necessarily see. So aside from enabling other attack vectors, we also wanted to enable you to run other tools, offensive and defensive tools in your environment, and have them respond and act the way that they're actually supposed to. So there's been a couple autopwn type tools coming out recently. Icebreaker and Death Star are two examples that I put in here, both written by a guy from Coalfire, and they both kind of rely on having active user sessions and cached credentials and an Active Directory set up. You really need users in your lab environment and sessions running for these type of tools to really work the way they're intended to. So by adding simulated users to your lab, you can check out these types of tools and see how they act before you go and use them on an actual engagement. We were actually at a BSides in Salt Lake where they were demoing Icebreaker and what it does, and in the middle of the demo, to show the responder SMB relay type attacks that it does automatically, they had to go onto their other system and start mapping shares. And that's something that if you have a tool kind of running in the background, it's just going to already be mapping those shares and creating the type of network traffic that those tools need to run. Bloodhound's another tool that requires user sessions to really work. So what it does is it maps, if you run it on a box with a domain user logged in, it'll map your path to domain admin, and then it'll also do other types of directory, Active Directory enumeration. And again, the graph that you get out of Bloodhound is great, but it's only going to show up looking like it's supposed to if you have a bunch of users logged on. User simulation can also kind of enable tools that you wouldn't really expect to require it. So Mimikatz is everyone's favorite credential dumping tool. But if you have this big lab environment or even a smaller one and you're going around running Mimikatz on systems, you might be just getting a lot of local administrator hashes. If you have users configured to be running on those boxes, they'll have active sessions, they'll have logged in with their credentials, those credentials will be cached. So if you pop one of those boxes and run Mimikatz, it's going to look just like it would if you popped a box on an internal network that has a real user sitting on it. Same thing with Responder, we already mentioned. That type of man-in-the-middle traffic doesn't work unless there's actually traffic going back and forth between the systems. So those are kind of the main use cases that we tried to solve with our tool that we found were a little bit lacking in kind of a static lab environment. So Barrett's going to talk about what specifically the tool does to help solve those and how they work.
All right, so actual tool functions here.
3 main functions, and then configuring host is kind of an administrative bit of the tool that it needs to do everything else. So browsing the internet, mapping file shares, and opening emails, and we'll dive into details here. So browsing the internet, this is probably your biggest traffic source on most networks, is just users visiting websites, internal, external, whatever it is. This generates a bunch of different types of traffic: HTTP, HTTPS, DNS, and all the various queries and types of TLS negotiation and stuff that comes with those. So being able to see that kind of traffic makes a network look and feel normal to both attackers and defenders who use tools, and that's there. So to do this, we're using Internet Explorer. We're launching an actual active interactive application there. So start Internet Explorer, browse to one of a bunch of URLs, and then start spidering from there. Pick a random link on the page, go there, and with configurable pauses between those, but go X amount of links deep and then start over. So you get a lot of randomness of starting off of some news sites and Reddit and stuff, and clicking a few links in, you can end up a long ways away.
Yeah, so you can change that URL list, by the way, so if you don't want to browse Reddit on your corporate lab network or something and end up somewhere you're not supposed to, you should consider changing that. They're mostly news sites and everything, but maybe just take Reddit off of it. And there's also like a URL roulette.
Like a config file?
Yeah, we're going to go over that. There's a config file that you can.
That list is just in the script.
List is hard-coded, but maybe we'll add that to the configuration file.
That could be good. Mapping shares. This is really all about creating SMB traffic and the hashes that come along with that. So really important for tools like Responder and other spoofing tools and man-in-the-middle tools to capture that SMB negotiation. So when you try and map a share, Windows will look up that name a bunch of different ways, which gives tools a chance to respond to that, which is where Responder comes from, and then say, hey, I'm that share. And then once the target computer actually goes to authenticate, that's when you get the hashes. So here we're just coming up with a random share name and trying to map that. And then Windows will go through whatever's configured, NetBIOS and LM&R, after normal DNS, and ask everything, hey, where's that share? Opening emails, like we mentioned, huge attack vector here, needs to be practiced for people to be proficient at it. Definitely becoming the biggest security threat. Not that it was any more of a threat now than before, but some of the other threats are running out. People are getting better at web vulnerabilities and things. So phishing becomes kind of a proportionally bigger attack vector on lots of red team engagements. So we're using Outlook for this, just to keep it as realistic and physical and userness as possible. Does mean you need Microsoft Office to get this feature to work, but you can get a monthly subscription to that for $10 max. I think some of the single user ones are even cheaper, but shouldn't be a problem if you have a whole big lab environment set up.
Is that a version?
Maybe. It's only tested with the latest one, so somebody should find out. But yeah, so we're just creating a Outlook object, grabbing unread mail, and there's a pause in there that you'll notice during the demo of tell it to download mail, sit around for a minute, and then actually go open that mail. And then we're searching the body of the email for any links in there, and we'll open up those links in Internet Explorer. And we also open up any attachments in the default way that they would execute. So if it's an exe, that's just going to get run. If it's an Office doc, that'll get opened, and macros will get run. Because we're opening Office docs, or rather saving all attachments, to what Windows considers a trusted location. I'd have to look at the source. I don't remember what that path is. But there's locations where Windows will natively trust any file opened from there. So there's no prompting for macros or anything. It just goes.
When you do the double click on code level, or are you doing it as far as moving the mouse? Or is it
There's no. So it just takes the Outlook POM object. It'll parse through the email and save it to a file programmatically, and then just execute that file.
Okay.
It won't. So similar to a double click. We're not actually doing a double click, but the same effect.
It's the script equivalent of like, do whatever your default action is for this object.
Because I know malware looks sometimes for the actual cursor, the actual.
Yeah. Configuring hosts. This is important for some of these scripting functions to work. Like Outlook, you need to configure a registry key to allow programmatic access to the email objects. So this takes care of those problems. And with that, don't run it on computers you care about being secure, because it's letting scripts do a bunch of things. So I just mentioned the Outlook key, and it's also setting an Internet Explorer one, which gets rid of that default, like the first time you open up Internet Explorer and it says like, hey, like, would you like to configure it this way or that, or me to bother you later. That one gets rid of that so that it can actually browse websites. And we'll get into how the script runs on remote systems in a second, but it will configure users it's supposed to run as to be in the remote desktop group on those remote systems so that it can kick off those sessions. And with that, here's the configuration XML file. There's more to it. There's a sample in the GitHub repository that has all of the options. But here you can see we're configuring some options for how it's browsing the internet. So it's waiting a minute between links and going 5 links deep from its initial list. And we're also specifying it to run on a remote system there. So just giving it that host and creds to it. So when it goes to log in users, it'll do that with remote desktop, which means there's an actual interactive session there, and that will cache credentials on the system. And you'll see a bunch of remote desktop windows open up, can close all them. The script doesn't do it automatically at the moment, just because there's no guarantee of how long you need to leave that open to have the login definitely work. But it is a real session on that computer. It's not just a PS exec, here's one process running in some session 0 type of thing. All right, so before the demo, actually running things. These are all of the flags. Pretty simple. Standalone is when you want to run it on your local machine, and config XML is to pass it that config, which is for running it on remote machines where you specify all the hosts and creds. And then you've got your functions that it can actually simulate. So internet browsing, mounting shares, and opening up email. And then all will do all of the functions at once. So we'll see this in 2 seconds here, but local, running it with that standalone flag, and remote, giving it that XML file to specify remote systems. So the remote's really designed for larger lab environments where you don't want to log into more than 1 or 2 systems to kick this thing off. You can just let it free. All right. I'm going to pass this back to Chris to narrate the demo.
All right, so we're going to go over the kind of the local scenario first. So if you're just running it on a VM that you have, kind of like the lab scenario screenshot I showed before, and then we'll go over what it looks like to run the shares function and then the Internet Explorer function. And we're going to show you a responder as well, which is not up there.
Yeah, sorry while I struggle with screens here.
We don't have Wireshark running. We're going to run responder to show you kind of what the stuff looks like. So,
we need the admin. No, we don't for this.
Nope. So you don't need any type of administrative privileges when you're running this locally. It's just going to run under the context of whatever user that you have logged on. So you can just put the PS1 file on there, import the modules, and then invoke user simulator and give it whatever flags you want to run. So if you're doing IE and shares, for instance, when you run this, you should eventually see Internet Explorer pop up.
Oh, and you need the standalone flag.
Yep.
I know how to use this thing.
So this is going to launch Internet Explorer and start browsing to random web pages. So hopefully it stays Lipscomb safe, as they say. CNN, that's a safe one.
Oh God.
It's somehow.
It's a little behind, but it'll probably catch up eventually.
Yes, we're running PowerShell inside of CNN.com now. There you go. So it's going to now parse the website there, and in the background you should see it browse a few different links in there as we show you that it is indeed. Yep. So we also use the shares flag, so it should be every 30 seconds or so manually, or there, that was lucky, but it's right on the 30-second. So it's generating those random share names. You can see there it requests something really weird, wgw blah blah /sendcreds, and since that's such a random name, it obviously doesn't know what that resource is, and responder is able to respond saying they are the resource and capture those credentials. So then you could take them and go and crack them and have domain user credentials to do all sorts of enumeration on the network. So that's what the local looks like. This, I believe, is it's loading something again.
I don't know. But it'll go places eventually.
Yep, it's doing a lot of clicking on its own CNN links.
You can take a look at remote here.
Yep. So with the remote systems, we have, I think, four or five desktops. We have them pre-configured, but we're going to run the configuration script anyways, just to show you what it looks like. So there'll be some red errors popping up on the screen, but that is just an error saying that the user we're trying to configure to log on to that system is already a part of the remote desktops group. So it's a friendly error that we should most definitely be catching and not displaying a bunch of red text, but are not quite yet.
And changing the source code, do you configure which SMB version that when it's mapping the file shares, instead of using version 3, use version 1? Just to simulate something like Eternal Blue or something like that.
Probably.
We're not making the request like that manually. It's more just telling Windows to mount a share, and it's deciding however it wants to deal with that. So it's going to do whatever the default on the operating system is, but
yeah, no, that makes sense. I don't know if we can specify the SMB version without admin credentials. Maybe you can.
I don't know. I mean, if Windows was configured that way, it would make it that way. But
definitely, that's something we can look into for sure. That'd be interesting. And another reason to not run this on actual systems you care about. Yeah. All right, so this is the configuration. You're just going to see those are the registry keys that we're setting on our target systems there, and the red error saying that we've already added that user to the remote desktops group. So now that our systems are configured, we can give it that same configuration file. So you use the same file for actually running the tool and for configuring all the hosts that you want to run it on. So we give it the same configuration file and run it with -all and hope everything goes well.
we can actually take a peek at that config file too.
Yep.
So this is the full config file. So the server IP is the IP of the server you're running this from, because it makes a share there where it hosts part of this script to then tell remote machines to run it. And then some running options, mostly delays between actions there, and then the computers we're actually going to run this on.
Keith hates his job.
Or Keith.
So how it actually runs remotely to make all this work and have the script run in an interactive session, we messed a lot with just doing remote PowerShell commands to try to run this, and it always started all of our processes in the session 0 non-interactive process. So if you were to log on, you wouldn't see that user with an Internet Explorer session open or anything like that. We'd have the process running, so there's the traffic happening still, but you don't get the same realism that we were really going after with a logged in user. So what it does is it hosts part of the functions of the script essentially up on the share, and then it remotely creates a scheduled task on those systems to pull down and execute that script with the parameters that we sent it. So if it's IE or whatever flags we've sent, basically.
As you can see, our amazing randomness, always picking CNN.
Yeah, there's one.
We did get a different one, so confirmed it's not broken. But
yep.
There you go.
Is there any way, is there a workaround for that, or like just so we can simulate if I'm doing like host-based, if I sysmon, I can see the actual user like trying to access that process and interact as the process.
I mean, it is running as that user.
Oh, it is?
So
I was saying to get around the issues that we were having with it running in session 0. So if you have sysmon, that's great. It's going to see these processes running under that user.
Okay.
Because we've created the scheduled task, so whenever the user logs on, that's when it kicks it off, and then since they have an interactive session in that logon, it'll open IE and Outlook and start mapping shares as that user. That's what we were running into too. We're like, wait, this is all happening, but like it's not acting like we want it to. So it's a little weird, like doing a scheduled task like that and then launching a remote desktop session to kick the processes off, but it works and you get some interesting sites.
And we can close all these. It would keep doing its thing, but we'll keep them open so we can tell what's going on. We are going to try a phishing demo here.
Yep. All right. Phishing is the last thing that we haven't done. So it generally tends to be the most dangerous part of the demo. It's also the whole lab is in Amazon. It's one of our Amazon labs. So hopefully the internet is cooperating. It seems pretty good here. So we're just going to send a phishing email to those users with a macro document, just the standard Cobalt Strike macro payload. And we can throw in a link in there too to show you that it does actually parse the body of the email and opens that link.
Browning, Keith.
Yep. A Prince and J Hobbs.
Link. And
when it parses the email for links, it's going to open that link, and then it's going to, in the same way it does the random browsing, it's going to create a new Internet Explorer process, open the link, but then it's going to kill that process 15 seconds later, so that if you're sending a bunch of phishing emails, practicing over and over or whatever, you're not going to end up with like 100 different Internet Explorer processes just eating up all the memory on your systems or anything like that.
Leave that in sight. that was it.
So there's a lot going on here, but hopefully we should see our beacon command and control channel come back from the macro that we sent.
And you'll see the Word docs open in these sessions too.
Yep, they should actually open up. And then we should get a 15-second Internet Explorer process going to Google.
This is still the local one, not the remote stuff.
This is the remote stuff. So the remote desktop sessions you see there are the remote hosts that we configured with the first command. And those are the ones we just sent the emails to. So hopefully, it generally takes anywhere from
Max 2-minute delay.
Yeah.
Does WinRM be up for your remote host to be able to get the command? Or how are you going to call to that remote host via PowerShell?
I think you do need WinRM.
Yeah, you do.
Yep.
Yeah.
So
because the scheduled task configuration is via PowerShell. Is I think the only thing I realized on it.
Yep, you do need to have some PowerShell remoting WinRM enabled, but besides that, the configuration script should run everything.
Oh, there's a Google.
Google worked. So we got our email. Hopefully it also decides to save the attachment and open it. And it did on one of them.
Probably one with Google.
So we're about to get much more back.
Yep, and you can see the Word doc over here. I'll click over. Can't see them both at once, but.
So you can kind of imagine how if you had this running on 15 or 20 different systems, great to have a lab environment that big, but you could kind of go through and either give a demo to your team or have new people practice what a phishing campaign is like and really come back with kind of realistic expectations of what's going to happen, with the caveat of every single user you're targeting is the user that you want to target, because they're going to always click on the link and open the attachment. All right, that's it for the demo. Any questions on that? There's some future work that we want to do as well. So we want to add in additional user behavior, mostly getting our phishing scenarios a little bit more realistic. So a lot of campaigns will just be to harvest credentials. So if you send it a login form right now, they'll have the user open that link and go to the login form, but it won't actually submit any credentials there. So we'd like to be able to somehow simulate that happening, and then also allowing drive-by downloads, watering hole type attacks, so that you can send someone a link that has your payload hosted on it, and then it'll automatically execute the hosted payload the same way that it does for attachments. And then we also want to transfer files to and from the shares instead of just mapping them. So identifying like legitimate home shares of the users that are logging on, and just kind of getting some additional network traffic just for the sake of realism, really. And then also we've considered doing a C# version as well. So if you have like a lab environment where you're trying to figure out how to get PowerShell off of all your systems, or you're doing other sorts of application whitelisting, or you just don't have PowerShell, we'll be able to just drop this as a PE and run it.
Also relevant from the blue team point of view, you're not going to fill up all your PowerShell logs with user sim commands.
Yep, and something we've run into in our own lab environments is that if you have a sim or similar tools deployed and you're trying to hunt for red team activity, a lot of times that's kind of the only activity that's in the lab anyways. So it becomes really easy to find your malicious PowerShell commands, because anything that's doing remote PowerShell administration or that type of stuff, you're easily going to be able to find that, because that's the only remote PowerShell is strings that attackers are running on systems. So we want to try to do something similar to invoke user sim, but more sysadmin tasks, kind of legitimate remote PowerShell commands, administer logins, different configuration changes. So if someone's making a GPO setting update or going in and changing a bunch of registry keys. When an attacker might be doing that for persistence, it might be a legitimate sysadmin activity as well. So if we can automate that type of behavior, it's going to make going into your SIM and hunting for the bad stuff more realistic without actually having to have like, a client's environment to poke around in or your own big corporate environment actually having access to your production tools. All right, that's it. Does anyone have any questions, or go ahead?
Does it do any sort of group membership where you have certain administrative accounts versus regular user accounts?
So it doesn't touch anything with the user group membership besides adding users to the local system remote desktop users group so they can do the interactive logons. But if you can set the configuration script up to pick whatever host you want users to log into, you also pick the users. So if you have admin users, you can easily just say, well, this user's an admin, I want him on this box, and then I want a regular domain user on this box, and kind of build that out in the configuration script. So when you run it, you'll have different levels of users logged in places.
Another question over here.
Yeah, so how well does it scale? Like, it sounds like you're using a fairly kind of limited one or two to just test out. Testing, like, I'm thinking about it like a CTF that involves 7 people, split between the red, blue, and gray team. And
Sure.
it's rather small, and so it would be really nice to have, say, 3/4 of the red team, another 3 times the red team simulated. The pie chat, as well as just to do tedious and non stuff the gray team doesn't like to do, like open emails.
Sure.
No reason it wouldn't scale, but I think we can only say we've tested it up to 6 or 7 systems at a time. But none of it's relying on a central server other than the initial launch.
Yeah,
So
the only thing I can...
those systems are the same. If it works on one of them, it'll work on all of them.
I can imagine there might be an issue with launching like 100 remote desktop sessions from the same kind of configuration host.
Those things are actually surprisingly lightweight too, so you might be okay.
But that's on our list of things to...
Make 3 config files and run one, and then close them all and run one, and close them all.
And so, like, how does it work from a user perspective? Is it able to cycle through, or have you tried using the cycle through users that you can work with the email thing, where like you've got one Outlook account and you're trying to use across 30 simulated users? How does it work for kind of gearing the users up so the red team doesn't go figure out, oh, this is the user that's simulated every time I can, or the blue team figure out, this is the user that's simulated every time I can safely just, we're going to whack this user, log everything they do from on it.
There's not really a...
there's
not a measure for that right now. The easiest feature in that direction to add would be to randomize the likeliness of a given email getting open. So just give every person a 1/4 chance of opening an email. Will definitely make it a whole lot less obvious who's definitely opening fishy emails versus not. And having 70 users would make that doable, versus with 4, you may just not get any opened emails.
Speaking of randomization, so again, thinking from like the blue team training perspective, which is from the focus of the CTF, if the blue team noticed that this user opens emails every 5 minutes on the dot, or 30 seconds or something, that's another indicator. Have you considered, like, when you instead of just statically setting this timeout, download like the stats library and just grab a value out of a random function, so it's always around 30 seconds, but sometimes it's more like 45 or something.
Sure.
Or even just
I can see that being useful.
I like that. We'll add a jitter feature.
Yeah,
just another value in the config XML to every 60 seconds. Plus
it'll
10% or 50% or whatever you want.
instead of standard deviation.
Yeah.
Pretty much. And so, and if you just generally thought about it like that side of it, it sounds like you designed it from the enabling red team to train in a realistic environment, but if you thought about enabling blue team to train in a realistic environment.
Yeah, that's certainly kind of the basis for the future work slide there of creating additional legitimate sysadmin type traffic in the Sims, and we haven't really looked at specifically how the users can be simulated better for a blue team, but certainly the jitter types features would go a decent way to making.
How hard would it be to orchestrate like spinning up and spinning down sessions in a individual uses in a fairly just hit the button and then tell it, we want you to create a pool of 100 users, spin up X amount at any given time, and be continuously spinning them up and down, so there's a lot of change on the network, so to speak.
Oh, so you just like pick a different user every few minutes and go act as them for a little while?
Conceptually, we're building the orchestration so we can spin up desktops. So we could like spin up a bunch of Gray Team desktops and then shoot this over to the Gray Team desktops, spin them up, run them for a while, and bring up another couple, just kind of randomly bringing user desktops on and offline, such that the blue team really has to stay on their toes to figure out what's happening. You can never just sit back, which is the problem
Sure.
now.
How are you spinning up the desktops? Are they like really fresh every time?
They are. They're basically out of the VM. Some of them are going to go to actual Gray Team people, but some of them can go to this. And essentially, you give the same account to a real person and to a simulated one at the same time. Like you can deploy this to their desktop while they're at it. And they're going to get some annoying pop-ups and stuff.
Yeah.
But it's going to help cover it. You could also say, like that guy goes away, he works his shift in the morning, well you spin him up virtually in the afternoon. And now the blue team's thinking he's a real person, and then you spin him up virtually and he does a bunch of stupid stuff, like that he may not have done physically, but now it's not really him, so they still think it's a real person. Like a lot of it is trying to make this very texture to the environment.
Your only limitation on scalability right now is just making the XML files, because there's not a more built-in feature for
and having
what
it
systems you're on. But
having it dynamic like that, my best idea as to how to get it to work would be to like configure an auto login or something when you spin those up with the script configured to run in standalone mode on those boxes.
I don't know if that made it into this future work slide, but it's definitely somewhere on the idea list of setting it up or making a configure function that will easily like make the user, every time they log in, this gets launched. Just kind of a more permanent simulation. You'd also need to come up with a undo that function.
Microsoft just launched a new script. They just launched it last week. It's Invoke Adversary.
Yep.
Yeah.
Similar to what you're, I think to yours, but they would be really well put together, especially for like a CTF.
Yeah, I haven't checked. I heard about it. I didn't check it out yet though.
It's Invoke
Adversary, yeah.
And it just so it's using the Migrate framework for different patches.
Yeah, and I know there's a lot of other red team automation type frameworks that have come out recently, like RTA by Endgame is one, and there's at least one other that I can't think of right now. But
Tax simulation is the
Red
box.
Canary.
yes, yeah. All right, great. Well, thanks for sticking around to the end. You're troopers. Yeah, go.
Can you show your GitHub?
Yeah.
Yes. There you go.
The other script will actually help out with bloodhound as well, because the credential will be cached in memory, and so just something else that bloodhound can do.
Yep.
I think that most of their credential access gets into that, which is
Yeah.
Will you guys be posting the slides?
We will. I don't think the slide deck is anywhere right now. There is a blog post and a video walkthrough of essentially the same thing as the live demo. I know the video is linked on GitHub. The blog's on, the video's on. And Iron Geek's really good about getting videos out really fast, so I'm sure by like tomorrow or
Probably up tonight.
yeah. Yeah, I've seen tweets throughout the day for the other ones, so
As long as I don't show up before your call.
give it an hour.
Too good. I mean, if they did, we could just press play.
Yeah, exactly.
All right, well, thanks, everyone.